final part to the Jesan 88900, also the Team Euro 3100 base station. And if you saw part 1, we resurrected it from our scrap set and put all the cut-off wiring back, but it will remain forever without a meter. And the bezel. There should be a front bezel like that, but it is missing on this one. Knobs will be in the dishwasher shortly, along with the lid. We've dishwashed the bottom lid. Now, I didn't really want to do this video tomorrow, but somebody has paid for a circuit diagram pack, and I'd like to get that out to them. But I've still got to prepare it by doing this video. So we've got the circuit. We've found out the microphone pinout, because that's not how it shows in the circuit. We've done the black and white photo with the alignment points noted. Because it has a crystal mixer board, it has those. We've got the layout diagram. What I'm not sure from the circuit, well, I don't need to be sure, is what the adjustments are. They're all very neatly laid out, aren't they? Because I can't read German, and I'll find that out in a moment. So the first thing you have to do on these is set the 10.24 megs. So we need our circuit diagram to find out which pin we're going to monitor to achieve that. And we're not going to do it on that board. Oh, I'm going to have to go and get the glasses out of the chapel where I've been working on a radiogram, because there's no room anywhere else. That's the London one. And we've got to start the one from, did I say Norway? No, I've forgotten where it's come from. So we've got to monitor the 10.24 on the crystal here. Somewhere. I'll see if we can do it on the Marconi test set. May be able to, may not be able to. So what you can't do, normally on a set with a single crystal phase lock loop, which is the reference, normally what you do is you're going to press transmit, you're going to look at the frequency it's transmitting on, and hey presto, you're going to adjust it until such time as you get the correct frequency. In fact, I don't know how right or wrong this is at the moment, so before we start upsetting it, okay, to do the 10.24, I've had to go on to one leg of the crystal, probably not ideal, and that's not far off 10.24. So I'm going to have to adjust the trimmer. Right when your probe's fallen off. No, it's still 10.2399. I just do not want to break my bestest trimming tool. It is moving now. Well, I think we're going to leave it as 10.2399. But I think you get the gist of what we're trying to do. What a faff is that, I've got to take the bottom off because you can't actually get to the pins of the IC because of the wax. So I don't really want to take the wax out. So we'll take that as being done. Right, I'm going to select channel 20 because at the moment it boots up on 9. Go into transmit, and let's see what the frequency is on transmit. It should be 27.79125, and what we need to do is to trim capacitor 209 to transmit correct frequency. That's pretty way out. But you do not set the frequency with that one, that's 10.24. You set it with the crystal mixer capacitor 209. Then we're going to set the receive one separately. So we're going to start with the transmit lineup at 14, 13, 12, 11, 6 and 4. You'll see there's 3 in the filter there which don't have cores. They're not missing, that's how it's supposed to be. So we'll switch over to the power meter. It's 3.5 watts, and bearing in mind I've been transmitting, very carefully adjust that one. I don't like them that early in the stage. So that one's quite clear, that's there. I'm not quite sure why this got discarded. You know, someone's taken the meter out of it. But was that after it was deemed to be useless? I mean, someone's paid £150 for this, or even more, 179, and then you can see he's got no marks from dust ingress through use, because you're going to get convection currents from the transformer. It's going to pull dirt in. It's absolutely as clean as a whistle. It's like it's never been used. And then you get all the wiring cut off. Perhaps somebody wants to turn it into a Space Invaders machine. I don't recall if we even get 4 watts out of these. It really doesn't matter. Oh, we do. Look at that. So that's definitely at peak. That's 4.5 watts. And then that falls as loose as they come. We'll tune that down to 4. Every time I take the tool out, it's popping back up again. I think it's got enough wax on that for it to stay put once I've heated it up. And 4 watt spot on it is. So that's our transmit lineup. Now we've got these presets, and it looks to me, and I can't verify because I don't know German. I could do a Google Translate, but I think we'll find that the bottom one is RX meter and the next one up is TX meter. In fact, I'll even write that on the notes because it will be. And is there a pen on here? Of course there's not a pen on here. TX, RX, because it's the same word and it's the only common denominator kind of thing you'll have. I better probably be looking at the layout. It's going to be clearer. So don't know what NF Pegel is, but we're going to find out. Sense is probably squelch, and hub's probably transmitted audio. I don't know. Is that deviation? We're going to find out. So at the moment, deviation is 1, 2. Is non-existent. Why is that? 1, 2. Wallow. Because wallow. 1, 2. Wallow. Because the thing's not on tune. Right, we'll get a little oscillator. We need to increase that. It's only 2. We want it to be 2.2. So we think it's the one which says hub, and we'd be right. 1, 2, wallow. Give it a little bit more actually. Assuming mic, if it's got mic gain, no it hasn't. Good. 1, 2, wallow. That's all right. So that, we go back to our diagram. I've done all this before, but I rather start from scratch than dig the notes out, which are probably in storage anyway. So we'll remember to put, we'll write that down when I go back into the next room and say that it's what it is. So that leaves us with NF Pegel. Might have to look that up. And sensitivity is going to be squelch, I'm absolutely sure. So we'll not touch anything more on there. I'm satisfied we've got transmit, and out of interest it's got variable transmit power. So if I press the variable power button, we have 4 watts as you can see, and if I turn down the control knob, not with that I won't. I've not got any knobs on this, and one's missing since I dropped it on the floor. This is a really useful feature, and it goes from about 800 milliwatts. Let's give you an exact reading on the lower scale. Yeah, 800 milliwatts up to the full 4 watts. I just will say again, you can only read power, you know, on a CB radio if you're into a dummy load. You can't read power on an aerial. I can transmit on our aerial here, and the power meter might swing across to 6 watts on a radio, but it doesn't mean it's doing 6 watts, so it's relative to SWR. It's still doing 4 watts. And conversely, I can key up and it only just moves the meter, and you think, well, I'm only doing 500 milliwatts. But you're not, you're doing 4 watts. It's because it's a relative SWR meter, and that's relative to SWR meter, a relative power meter. Probably why modern sets is pre-programmed to give you that many bars for what's deemed to be 4 watts. But in actual fact, if you turn the transmitter down to 100 milliwatts, it still gives you all the bars. So, you know, do you have fake ones, or do you have ones that people moan about because they are relative? I don't know, but you can only read it with a dummy load. So just get that one off my chest. So, we're done with transmit. That was straightforward. Receive isn't going to be as straightforward, and we're going to have to get it on frequency first. And that's with that other trimmer, and we'll have to use that with a marker oscillator. So, we'll get that back. It's going to be that trimmer, and which is capacitor to 212. We're going to put the correct frequency on our signal generator, which is 2779125. 79007, not James Bond. I don't know where Mr. Super Mega Chippy is. Not that much. And we're going to turn the tone off. So we've got no tone. We're then going to get our dead cheap Chinese little signal generator, which we use as a marker oscillator. and actually switch it on and set it for 10.695, which it is. Turn that one off. .695, the yellow one. Okay, so we'll plug in that. We're just going to wave this in the vicinity. I'm going to need more volume because I can't hear it. That sounds pretty spot on. Now I've got a low rumble. That could be the beat frequency with my signal generator. So let's adjust this crystal trimmer. Yep. Can you hear that noise? And we've nulled it. If I go the other way, so as it happens, it was absolutely spot on. Now that's vital. So you've got the 10.24. That's vital, it's set to 10.24. Otherwise the intermediate frequencies will receive the wrong signals. They'll not get the 10.695, they'll not get the 0.455. So your whole IF goes out. Transmit, receive with a marker oscillator. So you've got your signal generator, and I'll show you on the picture-in-picture, which I haven't put on. What a wally. So you've got the signal generator producing 27.79125. We've got the secondary signal generator generating 10.695, and that is the result. With that trimmer, you get a nulled beat, not a nulled marriage. I'll turn that off. And I'll turn that volume down. So it involves extra equipment to do that, like the DNT does and some of the others. So that brings us now, we'll do the detector, and while we remember to put picture-in-picture on, we will now go over to the oscilloscope. Which is there. Turn the bench light off. The detector coil is the yellow one down. It's yellow in my set, which is T7. So we'll put the tone back on. We'll put a 100 microvolt equivalent signal of S9 on, and we're looking at the oscilloscope at the recovered audio. I'll just turn the volume up just a tad so we can see. Rather than adjust the oscilloscope, it's easier to adjust the radio. That's the broken one, isn't it? Yes, Mr. Tango. Oh no, that's not the broken one. Don't know why, but I can't get the correct tool into that. But I can get the broken one in there. So now it was peak, there was no adjustment necessary, but we're trying to maximise what we've got. It's just across the speaker terminal, there's nothing clever about it, that's all we're doing. So we'll go out of that and into the cyanide meter. Turn the oscilloscope off. I don't know why that camera is not quite straight. There we go, that's a bit better anyway. So now we just want to go through the, and it's T1 down, so wherever it was T14 up to L4 on transmit, this time it's T1 down to T6. Detectors is always done separately. So I think 1, 2, 3, 4 on the front end, I think 5 and 6 at IF. or probably just 6. It's crystal filtered this as well. So we want about 4 dB on that, so we're not saturating the radio. So we'll start with T1, see if we get any improvement. Micro improvement. Another micro improvement. I'm going to turn the signal generator back down slightly. We always keep it as low a signal as is usable. That made a little bit of difference. Turn it back down again. I'm going to put a bit more signal on for the next one. And that's there. So let's see if we've got a new cyanide reading for the radio. For 12 dB cyanide, we've got 0.78 microvolts. Did we note what it was before? Probably just verbally. Anyway, that's absolutely fine. No problem at all. For 10 dB, the radio is doing 0.64 microvolts. And for 20 dB, if it will do it, some don't. That's all down to noise. It's 3 microvolts, so it's a bit noisy. It really doesn't matter. And can we hear? How low can we hear? We can actually hear down to about 0.24 of a microvolt. So we're going to park the signal generator at 0.3 of a microvolt and put it to standby and set the squelch to full. So it's going to be that preset which says sense, I'm absolutely sure, which is the top one. So first of all, I'm going to, I'll tell you what, we'll start at we're doing this the wrong way around. We'll do this at the top end first. Signal generator back on. 1 microvolt, 3 microvolts, 10 microvolts, once it's coming to 100, 30 microvolts, 100, it comes in as 100. But I want to prove whether that's the right preset, so I'm going to adjust it. Well, it doesn't appear to be, so we'll fiddle with the other one. It doesn't appear to be that either. Well, that has made a difference. You know, one of these could be S-meter sensitivity to the cell call unit. It could be cell call sensitivity. It's that one, that squelch. Yeah, so that's squelch. Squelch. And we don't know what that one is, and we're not really bothered. But I will just do a Google search before we wrap this up. So let's see where the sensitivity is now at the... I'll just make sure that's set back right. Yeah, it is. So we'll see where the sensitivity is. I'll go over to the attenuator, and what we're going to do is turn the signal generator to standby and set the squelch to threshold. Okay, switch the signal generator back on. And it's come straight in. That's nice and sensitive. Wow. So it comes in at comes in at 1.1 microvolts. It leaves about 0.15 microvolts, so that's very, very wide. Okay, so that covers that. It's got scan on this. I'll just see if it works. But it does indeed. Better go back to channel 20. There we go. I'll just see if I can look up that that hard word. No, I can't, because R92. I'll just see if we can see what it is on the circuit. It might be blatantly obvious, it might not. I can't see that obviously, but it's probably to do with the cell core. But some of you more experienced on this model may well be able to pop that in as a comment. So we've got everything else right, apart from that. So 9.5 out of 10, Mr. 21. So meter receive, meter transmit. Not that we can see that. Deviation, squelch, and anybody's guess. Now, has the dishwasher... I've not got the screws for this yet. The reason I've rushed through this is so I can get this information out to the customer who's paid for that information. So we're going to, the knobs are in the dishwasher, the lid's in the dishwasher. We're going to put this on an aerial. And we'll see whether there's anybody out there. We'll switch the test equipment off because it's done. I was really surprised that, incredibly, it was on frequency, on receive. But it does need all that extra equipment to verify. So we're now on the aerial. Let's pop the squelch down to a sensible level. Like nothing. Well, no, Roger. There's no change there, is there? Bit of something out there. No good buddies at 2:30 in the afternoon. So what happens when? What does it look like with the night light switched on? Ooh! It even has a warning light to tell you that the night light's on. If I borrowed that off the other set. So what we got? RF gain activated. We didn't want that activated. Roger bleep activated. Let's see what that sounds like. I'll just pop it to channel 20. Key up. Testing 1, 2. That's funny. Well, I'm not sure why that's not picking up the Roger bleep. VSQ is for when it's got the cell call on. To get rid of transmit power. Tone. Did it make any difference? Yeah, it does. And there you have it. Jesan 88900 also masquerades as the Team Euro 3100, and we can get those diagrams out now. There'll be on the air test. It'll probably be tomorrow when the screws have come and we can put it together and actually make it look in one piece without a meter. I must take that front bezel off and put it back on the other set. I think we'll photocopy that first. Thanks for watching.